There are a few forms with which we can graph a parabola: standard form, vertex form, and intercept form. The first form we're going to start with is standard form, which is represented by y equals ax squared plus bx plus c. As you can see at the top of here, I wrote y equals ax squared plus bx plus c. First step is to find the axis of symmetry, which is represented by x equals negative b over 2a. So the reason why we want to find the axis of symmetry, or x equals negative b over 2a, is because this is the x-coordinate for the vertex, which is the maximum or minimum point, depending on if you have an upwards parabola or a downwards parabola. And an example is y equals x squared minus 4x minus 12. So let me just write that down. Y equals x squared minus 4x minus 12. So the first step is to find the axis of symmetry, x equals negative b over 2a. So we are going to plug in, according to our given equation, negative b over 2a. So our b is negative 4, so negative and negative is positive, so that would just be positive 4. So x equals 4 over 2 times a, and the a is just the imaginary 1 in front of the x squared, so we know that 2 times 1 is just going to give us 2. And 4 over 2 is 2. So our x value is 2, which gives us the x-coordinate of the vertex. Now, to get the y-coordinate of our vertex, we just have to plug in the x into the original equation. So we're just going to plug in the 2 and plug it into the y equals x squared minus 4x minus 12. So y equals 2 squared minus 4 times 2 minus 12. So 2 squared is going to give us 4, minus 4 times 2 is 8, minus 12. So y is going to equal, well, 4 minus 8 is negative 4, minus 12 is negative 16. So that's going to give us the y-coordinate of negative 16. So our whole vertex is going to be the x-coordinate, or the axis of symmetry, in addition to the y-coordinate. So together we have our x value of 2 and our y value of negative 16. So now we know that the vertex is 2, negative 16. 2, negative 16. And that is our vertex. The next step is to draw a table, putting the vertex in the middle of 5 or 7 points so that we can actually graph it. So over here, I'm going to graph. As you can see, I set up the graph. And we are going to, over here, set up a little table. X, Y. So in the middle of the XY chart, we're going to put our vertex, which is 2, negative 16. So 2 for the x and negative 16 for the y. And then we can just put in on top, starting from negative 1 and ending with 5. So then we take all these points and plot them. So as you can see, everything matches up, and when I just draw the line through it, connecting the points, you can see it is an upwards parabola and has the lowest point or minimum value of 2, negative 16, 2 being the x-coordinate, y being the negative 16 being the y-coordinate. And just to clarify, the reason why the parabola was upwards was because the a value was positive. However, if the a value at the beginning of the equation y equals ax squared plus bx plus c were negative, then we know it was a downward deal. So the last step is to find where it's decreasing and increasing, and then the domain and range. So we know, if we just open this back up, that our graph at the vertex, right at the lowest point, -2, -16, that is where it changes direction. So it's going downwards and then changes direction and starts going upwards. And that's where we get the parabolic shape. And so we know that initially it is decreasing. So what is it decreasing from? It is decreasing from -infinity all the way down to 2. And then it increases from 2 to infinity. And we always go by the x value. So that is why we said till 2 and then 2 till infinity. Then we want to find our d and r value, domain and range. And the domain, you can see here that there are no real restrictions. It can be any value. And because it doesn't have any restriction, we know that it is all reals. In other words, -infinity to infinity. As for the range, we know that it does have a restriction because the lowest value is -16 and it does not go any lower. Every other y value is higher than that point, so we know that the range is from -16 to infinity. And that pretty much covers it for the standard form. Now we're going to move on to the vertex form. The vertex form is represented by a times x minus h squared plus k. So I'm just going to write that out. So we know that the vertex equation is y equals a times x minus h squared plus k, and the vertex is going to be at hk. And essentially, the vertex has the same function as the last graph we looked at, just using different letters to represent it, h and k. And the first step, like last time, is to find the vertex. So we're going to do that by completing the square. And we're using the same equation we did last time, which was x squared minus 4x minus 12, and setting that equal to y, but we're going to solve it a little differently. So y equals x squared minus 4x minus 12. So the way to complete the square is you first take the whole number and move it to the other side. So this is the -12, so we're going to add 12 to both sides. And what we get from that is that y plus 12 equals x squared minus 4x, because -12 plus 12 equals 0. So to have a third term, you take half of the b value, being -4, so half of -4 is -2, and squaring it. -2 times -2 gives you 4. So you add 4 to both sides. So we already had y plus 12 plus 4 would be y plus 16 equals x squared minus 4x, and we added a 4, so plus 4. Now we are able to factor out to get our x value and then solve for y. So x times x, and this plus sign here indicates that both of them are going to be whatever sign is here. So this is a negative, so we know that both are going to be negative. And then we have 4, so to break 4 up, we have 2 and 2, because 2 times 2 is 4, equals y plus 16. And if we just want to double check that, you can just factor it out. X times x is x squared, x times -2, -2x, -2 times x, -2x, so -2x plus -2x would be -4x, and -2 times -2 is 4. So that was just basically foiling it out. Now that we have that, we can add the 16 back over here to get y by itself. So y equals x minus 2, and we can just say x minus 2 squared, since x minus 2 times x minus 2 can just be shrunk into 1, plus 16. I'm sorry, minus 16, because you just subtracted it from this side, because this was y plus 16, so you're subtracting the 16, which is going to give you a -16. So now you know that if you set x minus 2 equal to 0, you have 2 equals x. So we know that our x value is 2. And then once you plug in that, 2 minus 2, 0 squared is 0, and you're left with just y equals negative 16. So that is how we used the vertex form to solve for the vertex, which was hk, and hk here is 2, negative 16, exactly like the first one, we just solved it differently. So we can just say vertex is 2, negative 16. And so we can just write under that the 2 would be the h here, and the k would be the negative 16. So I just wrote that underneath. Okay, the next step, we have to draw a chart and plot the points exactly like we did last time. So instead of redoing that, I'm just going to open up to here, and I'm just going to show exactly what we did last time. We set up our x and y chart. We put the vertex, which here would be the hk, or the xy, that was in standard form, and we put that in the middle, and then we do a few points above, a few points below. So we did the x values of -1 through 5, and the way that we found out the y values, if you wanted to do it out, which I didn't, but you just plug in the x into the original equation. So here or there, you just plug in the x. So like if you wanted to do 0, for example, you would do 0 squared is 0, minus 4 times 0 would just be 0, and you're left with negative 12 equals y. So that's how we got that the y for 0 was negative 12, and you basically just do that for all the x values, just plug in the x and then you'll solve for y, and that's how we got the y values. And then we took all those points and plotted them and found that the parabola was upwards, and we do the same exact thing for figuring out increasing, decreasing, domain range, same deal, same values. So the last form we're going to look at is called intercept form, which is y equals a times x minus p times x minus q. And I wrote that out right here. And the p and the q are our two x-intercepts, and they're the points where the graph crosses the x-axis. And it's possible that there are 2, 1, or 0 x-intercepts, and if the roots are imaginary, the graph doesn't cross the x-axis, and if the two roots are the same, the graph touches the x-axis, and in this example, there are 2 roots, but they are different, and so what that means is that the vertex is midway between the 2 points. So we're going to write out our equation, which is y equals x squared minus 4x minus 12, and we are going to set y equal to 0 to find the x-intercepts, and we're going to factor this out, and that's x, and because the last sign is not a plus sign, we know that they're going to be different, so there's going to be a plus and a minus, and what times what would give us 12, so we can try 6 and 2, and this would be positive 2, and then this would be negative 6, because 2 minus 6 would give us negative 4. So equals 0, and so then we know if we said x plus 2 equals 0, and x minus 6 equals 0, we would get x equals negative 2, and x equals 6. So we know x equals negative 2 and x equals 6 are our x-intercepts. And what we're going to do is say p plus q divided by 2, which is going to give us the x-coordinate of our vertex. So we're going to plug in the p and q, which are x-intercepts, so we're going to say negative 2 plus 6 over 2, which is going to give us 4 over 2 equals 2. And so 2 is our x-coordinate of the vertex. And so now we're going to substitute x into the original function to solve for y. Y equals 2 squared, because x value we found out was 2. minus 4 times x, which is 2, so times 2, minus 12. So y, once again, is negative 16. So now, just to clarify, p plus q over 2 is how we solved for the x coordinate of the vertex, because we were adding our x-intercepts and dividing by 2 to get the middle x coordinate of the graph, which would be the x-coordinate of the vertex. And then f of that would be the y value for the y coordinate of the vertex. And so we know that now y is negative 16, x is 2. And then the last step is to make a chart and plot the points, which we once again already did right here. As you can see, chart, points, and it comes out to the same thing. And that is essentially all there is to the 3 forms. Once again, there are 3 forms for parabolas. There's a standard form, there's the vertex form, and the intercept form. Standard form, which was y equals ax squared plus bx plus c. The vertex form, which is y equals a times x minus h squared plus k. And the intercept form, which is y equals a times x minus p times x minus q. And using all these forms, we were able to find out the vertex, and we're able to get a set of points and plot them and to make a graph. Parabolas show up in our everyday lives, from McDonald's signs, to a water fountain, to dolphins jumping, to roller coasters, rainbows, and even tossing a slinky. Parabolas are everywhere.